Okay, and this is solving quadratic equations by quadratic formula. For the bell work, we're just going to refamiliarize ourselves with the quadratic formula. Okay, here I'm just asking you to set it up. I'm not asking you to simplify and work it out. I just want to see you to set it up. Okay, so identify the values of A. Is a 1 here. The value of B here is 2, and the value of C here is -3. Okay, and again, quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and all we're going to do is replace the A, B, and C with those numbers. Okay, and again, we're not simplifying at this point. We're just going to set it up. Okay, so here the opposite of 2 is -2 plus or minus square root. B was 2, so notice I'm going to put that in parentheses. Squared, that's huge, because if you have a certain kind of calculator that has the parentheses function as an option, then you're going to have to put that on there for when you square something, because otherwise it's going to give you the wrong sign. Okay, so make sure you do that. So parentheses 2 minus 4 times the value of A, which was 1, times the value of C, which was -3. Please note that I extend this all the way out past that last set of parentheses, divided by 2 times the value of A, so 2 times 1. Okay, and again, all we're doing is setting it up right here, okay, for bell work purposes. Number 2, value of A here is 3. The value of B here now is -6. And the value of C is 5. Okay. Remember, again, it has to be in standard form. So if I don't give you the problem in standard form, you have to put it in standard form. That again is x squared, and then the x term, and then the constant. Okay. If something's not there, so let's say the x is not there, you can put a 0x in the middle and have those 3 spaces. Okay. If you don't have an x, that doesn't mean the constant becomes the b value. It's still the c. Okay. So then we plug in. So again, quadratic formula is right here. So I'm going to do it in green. The opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And again, just replacing things. The opposite of b, the opposite of -6, is +6. Plus or minus b squared, so square root -6 squared minus 4 times the value of a times the value of c all over 2. Ooh, that's a horrible 2. 2 times the value of a. Okay. Quadratic formula here by scratch. I'm not going to actually do this, but understand that this is an option that you can go explore and find on the internet, or if sometime that you actually want to see this, we can work this out together in class. But I do know that at some point I actually offer the ability to do this as extra credit on a paper, so keep that in mind. Okay. So procedure here. And then we have examples coming up after this. Okay, so procedure, you're going to put the equation into standard form and set it equal to 0. Okay, so again, what's on the left side doesn't matter. It could be the 0 or it could be the expression. But whatever it is has to be in standard form. Okay. Step 2, you're going to set up the quadratic formula. Step 3, then you're going to simplify the square root expression and then reduce if possible. Okay, so sometimes you're going to take the square root of something and it's going to be a nice number. You're going to have to then break it apart more. Other times it's a square root that can be simplified and we can simplify that. Or other times it's a square root that doesn't have any simplifying characteristics, so then we would just leave it alone. Okay. Recall though, if there is a negative number under the square root, you will end up calling that I because that negative comes out. Okay. Okay, so 2 examples on this page. Number 1, okay, is already in standard form on the left-hand side, x squared plus 7x plus 9, and it's already set equal to 0. So we can just go ahead and identify a, b, and c, and go ahead and set up the quadratic formula, and then go ahead and work out the quadratic formula. Okay, so the value of a is 1. The value of b here is 7. The value of c here is 9. Okay. And for the purpose of space, let's go ahead and just put the quadratic formula in the middle there. I'll put it in green. So again, the equation here is going to be x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and again, I'm just plugging in the values of a, b, and c now. So over here, I'm going to have x equals, maybe, x equals, the opposite of 7 is negative 7, plus or minus the square root. I have 7 squared minus 4 times 1 times 9 all over 2 times 1. Okay, and I'll alternate colors here so that we can make sure that we can keep visually things separated here. I'm going to then focus on just underneath that square root. So I have x equals negative 7 plus or minus square root. 7 squared is 49. Negative 4 times 1 is negative 4. Negative 4 times 9 then is negative 36. Over 2 times 1, which is 2. Continuing then, again, we're going to simplify what's underneath that square root. 49 minus 36 is 13. So x equals negative 7 plus or minus the square root of 13 over, all over 2. Okay, so now we're getting to this point where we have to make a decision. Is the square root a perfect square? No. Okay, 2 closest to it would be 9, which is 3 squared, and 16, which is 4 squared. Okay, 13 is not one of those. Then the question is, do we have any perfect square factors of 13? 13 is actually a prime number, which means its only factors are 1 and 13. So that means that this is in fact our answer. Okay. On some standardized tests, just for the purpose of making sure that I reiterate things like this, on some standardized tests, they'll separate this and they'll have it as negative 7 plus the square root of 13 over 2. And then they normally separate by a comma and have negative 7 minus the square root of 13 over 2. Okay. If you prefer to do that and see both answers, that would be okay. However, my suggestion is we just leave it right here, okay, and have that as our answer. Moving on. Number two, why I didn't go back and not give you something that was already in intercept form, or sorry, factored out form. I don't know, but let's, for the heck of it, go through the process of distributing. Okay, so if I have x plus 1 times x minus 2, I have x times x minus 2, and then the 1 times x minus 2 equals 0. And again, I'll alternate colors so we can see. X times x is x squared. X times negative 2 is negative 2x. 1 times x is 1x. And 1 times negative 2 is negative 2. Equals 0. Combine then those middle terms. We have x squared minus x minus 2 equals 0. Now, the left-hand side is in standard form. The right-hand side is a 0. So I can go ahead and continue my process. The value of a is 1. The value of b is negative 1. And the value of c here is negative 2. Again, then plugging into the quadratic equation, or sorry, the quadratic formula, which is above, we have x equals the opposite of negative 1, which is 1, plus or minus the square root b squared, so negative 1 squared, minus 4 times a times c. All over. Two times the value of 1, or value of a. Again, then working out and simplifying some things. Negative 1 squared, so we have x equals 1 plus or minus the square root. Negative 1 squared is 1. Negative 4 times 1 is negative 4. Negative 4 then times negative 2 is positive 8, so plus 8 over 2. 2 times 1. Which then gives me x equals 1 plus or minus the square root of 9 all over 2. Square root of 9 now is a perfect square. So x equals 1 plus or minus 3 over 2. Okay, and be sure that you have plus or minus 3. I'm not sure why it happens, but it always seems to happen at this point that when people take the square root, they think a square root has to be there still. If I take the square root of 9, I get 3, just 3. Not the square root of 3, just 3. Okay, so I don't have to have a square root anymore if it goes away. Here then again, I have this problem where I have no square root, so I can then continue my process. So I'm going to split this up into two things. I have 1 plus the 3 over 2, and then I have 1 minus the 3 over 2. 1 plus 3 is 4 over 2, which then reduces to become 2. And 1 minus 3 is negative 2 over 2, which becomes negative 1. Okay. Second 2. So 3 and 4 of 6. Again, now we're going to look and see that these problems are either A, not in standard form, or B, are not set equal to 0, okay, or both. So here on the left side, on number 3, I'm going to have to move that 3 from the right side of the equation to the right side, or sorry, to the left side. So I'm going to subtract 3. And here, if I have a like term, again, I'm going to put it underneath it. Okay, we want to make sure that things are in standard form, so this is still in order if I just go ahead and subtract. So 5x squared plus 16x, now that becomes minus 9 equals 0. Since it's in standard form, I can go ahead and identify my A, B, and C values. A equals 5. B is equal to 16. C equals negative 9. And again, for the purpose of being able to utilize it, let's put this over in one spot. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, and again, I'm going to plug into that. So now at this step, x equals, the opposite of 16 is negative 16, plus or minus square root of 16 squared minus 4 times a times c over 2 times a. Okay, 16 squared is 256, so I have x equals negative 16 plus or minus square root 256. If I take negative 4 times 5, I get negative 20, and then negative 20 times negative 9 is positive 180, so plus 180. All over 10, 2 times 5. Again, then shifting down and continue to work it out, x equals negative 16 plus or minus the square root. This is 436 over 10. Okay, and what we'll notice here is that 436 is not a perfect square. Okay, however, it does have perfect square factors, so we have to simplify this. So the square root of 436, I want to take 436, and I'm going to list all the factors of 436. Okay. 1, and in 436, I have 2 and 218. Then I have 4 and 109. Okay, you can try your luck between 5 and 108, but you're not going to find much, actually nothing. Okay, so that's a lot of time that you would waste. So we're actually going to use the 4 and the 109. And again, I'm going to separate this. So x equals negative 16 plus or minus square root of 4 times 109 all over 10. And then I'm just going to take the square root of 4, which then gives me x equals negative 16 plus or minus 2, because the square root of 4, times the square root of 109, which stays underneath the square root. Let's make that 9 a little bit better though. All over 10. Okay, at this point you wouldn't be incorrect if you stopped. However, you would not be finished because notice that all three numbers here, this one in front, this one in the denominator, and the one in front of the square root now, are all divisible by something. Okay, which means I can take 16, 2, and 10 divided by some number that's in common. So I'm going to divide all of those by 2. Okay, when I do that, that's going to give me -8 plus or minus, and again you can put the 1 if you need to, square root of 109 over half of 10 is 5. And then that would be my answer. Okay. Number 4, again, I need to move some stuff. And it doesn't matter here, and I don't think I've said this yet, if the x squared is negative, that's okay with this setup. Okay. X squared has to be positive on everything else that we've done so far. However, here, it doesn't have to be. Okay. But I'm going to shift everything to the left just because it makes it a little bit easier. I'm going to add 5x. I'm going to add 1, so I'm going to add 5x in the middle here because that would be the middle. And then add 1 directly below that 3 because they're like terms, which gives me 3x squared plus 5x minus 2 equals 0. And again, now I'm going to identify my values of a, b, and c. A equals 3. B equals 5. And C here equals -2. Okay, now that we got that done, you go into setting up the quadratic formula and then simplifying. So here, x equals the opposite of b, the opposite of 5 is -5, plus or minus square root 5 squared minus 4 times 3 times -2 all over 2 times 3. And again, working it down now, so x equals -5 plus or minus the square root. 5 squared is 25. -4 times 3 is -12. -12 times -2 is positive 24. And 2 times 3 is 6. 25 plus 24, so x squared, or x equals -5 plus or minus square root of 49 over 6. Okay, and again, at this situation, we need to then identify if the square root is a perfect square or not. 49 is in fact a perfect square, so that becomes x equals -5 plus or minus 7 over 6, which then allows me to break it up into my two cases. That gives me -5 plus 7 over 6, and -5 minus 7 over 6. -5 plus 7 is 2 over 6, which reduces to be 1/3 if I divide top and bottom by 2. Over here, -5 minus 7 is -12 over 6, which reduces to be -2. -12 divided by 6. Okay, and last two problems here. Again, We need to get this set equal to 0, and it doesn't matter which side it goes to, but then we need to then again also get it set equal to 0 and in standard form. Okay. So I'm going to add just the 3x. I'm going to get that, or sorry, the 3. I'm going to add 3 to both sides. Okay, and when I simplify here and write things down, I'm just going to go ahead and order it like I need to. Okay, in standard form, this becomes 0 equals, I need the 2x squared first, so 2x squared, positive 7x, and then plus 3 at the tail end. Again, let's write the quadratic formula in the middle of the page here so I can utilize it for both. The opposite of b, plus or minus the square root, b squared minus 4ac, all over 2a. Here I can identify my values of a, b, and c. A is 2, b is 7, c is 3. And then again, going ahead and plugging in then. So we have x equals, the opposite of 7 is negative 7, plus or minus the square root, 7 squared, minus 4 times the value of a, times the value of c, all over 2 times that 2 value of a. Let's fix that 2 there. There we go. Continue the process. Again, simplifying, x equals, we got negative 7 plus or minus the square root. 7 squared is 49. Negative 4 times 2 is negative 8. Negative 8 times 3 is negative 24. All over 2 times 2, which is 4. Continue the process here. X equals negative 7 plus or minus the square root of 25 all over 4. And the square root of 25 is 5. So we have x equals negative 7 plus or minus 5 over 4. And again, then I'm just going to work this out down below, because again, I don't have any square root now, so I can go ahead and continue. I have negative 7 plus 5 over 4. I have negative 7 minus 5 over 4. And negative 7 plus 5 is negative 2 over 4, which reduces to be negative 1/2. And negative 7 minus 5 over 4 becomes negative 12 over 4, which is negative 3. Okay, and these are similar to the other problems too. If you go back and take these answers that we get and you plug them into your equation and make sure that the left-hand side is equal to the right-hand side and they are correct, then you're good. Okay, if the left-hand side does not equal out to be the right-hand side, then you should work it out again, or check your math if you've written it all out, okay, because something went wrong. All right, last one, number 6. Again, it doesn't matter if my x squared is positive or negative, so I'm just going to go ahead and leave that there. I'm going to move this 19 over. So negative 6x squared plus 3x plus 19 equals 0. Again, identifying my a, b, and c values. So a is negative 6, b is 3, c is 19. And again, using that quadratic formula equation up there in the middle, I have x equals the opposite of b, so the opposite of 3 is negative 3, plus or minus the square root, b squared, so 3 squared, minus 4 times a, or negative 6, times c, which is 19, all over 2 times negative 6. Okay. X equals negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times negative 6 is positive 24. And 24 times 19 is 456. Two times negative 6 is negative 12. Okay. Combine underneath that square root. We get x equals negative 3 plus or minus the square root. It'd be 465 over negative 12. Okay, so again, at this point, we need to check to make sure that square root of 465 is either A, not a perfect square, or is a perfect square. And then B, if it's not a perfect square, can I simplify? Okay, so we have to find the factors of 465. So the factors of 465. 1 and 465. 3 and 155. 5 and 93. 15 and 31. Okay. You'll notice if you go through this list that we in fact don't have any perfect square factors. So this is the answer. Okay. However, some people would not like this as an answer. Okay, let me tell you why. I will take this as an answer. In the denominator, you should typically have a positive value. So here we have a negative value, which is an issue again for some people. In standardized tests, we don't typically have a negative number in the denominator either. Okay, so what can happen here is that I can just change the sign of everything. Okay, if I change the sign of this, I have to change the sign of this as well, and the sign of these two. But notice with the plus and minus, if I change plus to a negative, and I change that negative to a plus, I still get plus or minus. So I could rewrite this as 3 plus or minus the square root of 465 over positive 12. Okay, again, either one would be okay. If you move things to the opposite side of the equation at the beginning, so if we would have moved that so that the negative 6x squared was positive, then we would have ended up with that bottom one anyway. But again, that's up to you as far as things go. Okay, and that is all for this section. So if you have any, again, questions, comments, or concerns, by all means, feel free to reach out to me. But my suggestion for things like this is that you get very, very familiar with the quadratic formula, because this will be the method that most of you use pretty much every time that you solve a quadratic equation. Okay, you do have options. However, this is probably the easiest one to remember. Okay.